Okay, fine. So let's start. So hope you people have gone through the weekend records where I've discussed about the collection API and JUnit. So please make sure that you go through them. JUnit framework and collection API both. Okay. So today I'm going to resume the collection API discussion. So in the last class, I was talking about comparable interface. If you people remember, comparable, right? What is comparable? Yes, what is comparable interface? Why do we use it? Yes, comparable interface. Yes, very good. So to implement the logic to compare two objects, you can say yes. In order to implement the logic to compare two objects, you see in the comparable interface, we got this compare to method. Okay. Now in the last class, we have implemented this comparison logic. You see, we were trying to compare the objects using the comparable interface. You see, we implemented this. You got this compare to method. Okay. Yes. Now here, now on what basis we are comparing the objects here? Yes. On what basis we are comparing the objects? Based on the ID. As of now, we are comparing the objects based on the ID. Okay, this is one of the requirements. Let's say the client needs this. And why is this required for us? Actually, why we need to write this why we need to write that logic to compare the objects here? Why do we need it? Yes. Why is this used? The comparison logic. Okay, to compare the objects, but in what situations will compare the objects? What is the need for comparing the objects? Especially for sorting purpose, as we have discussed, right? For sorting, to sort the elements. So, you know, this product objects, you will find that they will be compared based on the ID, and they will be sorted based on the ID itself, because the comparison logic which you are providing, the objects we are comparing based on the ID itself. So the elements will be sorted in that order itself, okay, based on the ID. Now, let's say your client wants you people to provide the logic to compare, sorry, to sort the elements based on the price. The client wants you people to sort the product objects based on the price. They want this logic as well. Which logic? To compare, sorry, they want the elements. They got this requirement also. They want the elements to be compared based on the ID, but sorry, sorting, they want to sort the elements based on the ID, but they also want to provide an option to the users to sort the products based on the price. Sort the products based on the price. So what you'll do? What do you think? Hope everyone got this, right? Let's say our clients provided a requirement. So the requirement is we need to sort the products based on the price in the ascending order. Let's say price ascending order. So what to do? At least hope you people understood the requirement, right? Can I have yes or no? Okay. In this case, okay, good. So I'll tell you people. Now, in this case, what you'll do is here, we'll we'll have to provide that comparison code separately because already we have implemented this compare to method now here, which compares the objects based on the ID. But now we can't do anything with this. Okay. So if you want additional or some other logic to compare the objects based on the price or something else, in that case, now we need to define it separately again. Okay, so we can't do it here in this class again because already we have implemented one logic to compare. Okay, so in this case, what you need to do is use another interface called as comparator. Comparator. So where is this comparator? So comparator interface is in java.lang package. Okay, yes. So let me show you people this interface. Okay, don't worry about all those things here. Just check this compare method. So this is the method which you need to implement, okay, to provide some other logic here or to provide the logic to compare the objects based on some other criteria. Yes. Already we have provided one comparison logic to compare the objects based on a particular criteria, that is ID. Now additionally, we'll provide the comparison code to compare the objects based on the price, so that the elements will be sorted based on the price itself. Yes, but how it works, that you need to see, then only you'll get more clarity on this. Okay. Yes. Now I'll define a class here, known as product comparator, let's say. I'll make this class implements comparator interface. Okay. So now we want to compare the products based on the price. That logic we need to provide. See, if P1 dot price get price is get greater than P2 dot get price. Okay. So in this case we'll return 1. Okay. Yes. Just a minute, please. Just a minute. Just a minute. Yeah, I'm sorry. So here you see I'm writing this logic. If the first product's price is less than second product's price, so we'll return -1. And if these two conditions fail, that means the price is equal. So in that case, we'll return 0. That's it. Okay. So now in this method, we got that functionality to compare the products based on the price, so that they can be sorted based on the price later on. The sort method will be using this logic. Okay. Yes. Fine. Okay. Now can we use it? I'll show you people. Now first of all, this logic is clear for you people, right? Yes. Next, here, now you see we are adding that product objects to a vector, and they are not added in the order. You see, the first element which is added is 102, then 103, then 104, and then 101. So we'll call the sort method and we'll pass the products object, the collection object. We'll pass the collection object to the sort method. Now, can you people tell me, as of now, sort method, how it is going to sort the elements? So internally, as I told you people, it uses that method. Which method it uses to compare the objects? Yes. By default, it uses which method to compare this product objects and sort them. Very good. So it uses the compare to method, which we have implemented in the product class, which is part of your comparable interface. Okay. So that means now the elements will be sorted based on what? The elements will be sorted based on ID, right? Let me show you people. I'll display them. You see, the elements are sorted based on the ID itself. Yes. Okay. Now, but what if I want the product objects to be sorted based on the price in the ascending order? The product objects should be sorted based on the price in the ascending order. Finish. Yes. So I want this elements to be sorted based on the price now. Yeah, in this case, this is where your comparator, that additional class which we have defined. Okay. Yes. In this class, we have defined that logic to compare the product objects based on the price. Now this logic should be used for comparing that objects, and then they will be sorted. Now the question is, how do we ask the sort method to use that compare method which is in that product comparator class to compare the objects so that the product objects can be sorted based on the price? Okay, how will you do that? You see, all you need to do is just pass that product comparator object reference. That's it. You got another method, sort method, which takes two parameters. So first, sort method, it only takes that one parameter, that is collection object reference. Now this sort method takes two parameters. Okay. Yes. This sort method takes two parameters, the collection object reference as well as the comparator object reference both. So now sort method will use that compare method defined in this class, which we have implemented to compare the objects based on the price. right? Yeah. Now you see the elements will be sorted based on the price here. Just run this code. So I'm not displaying the price here. Let me display the price as well. Okay, product price for each product. Product.get price. Okay, all the prices are 100 itself. Sorry. So let me change the product price. Okay, make it 2000. Okay, let me run this code. You see, they are in the ascending order. The product records, the product objects. See now how they are sorted, that elements based on the price in the ascending order. Yes. So is this clear for you people, all of you? Any questions in this regard? Okay. Now, last test for you people, whether you people understood the comparator, why to use it. First, suppose, what if I want, okay, I got this logic to compare the elements based on the ID and price. Now we can use any one of this methods as a compare to, which is comparing the objects based on the ID, and compare method, which is sorting the elements based on, which is comparing the elements based on the price. Now first, suppose we got another requirement. We have to, let's say, sort the product objects or elements based on the name. Then what you'll do? Based on the name, the elements have to be sorted. Then what? So your client has asked you people to also make sure that you provide the code to compare the objects based on the name. Sorry, to sort the product objects based on the name. Okay, product objects have to be sorted based on the name here. So what to do? So what you'll do? If you people are supposed to provide the logic to compare the, sorry, to sort the elements based on the name. Name is string type, the alphabet. Then what? To sort the elements based on the name. So what are we supposed to do now? Yes. Yeah. So how to do that now? Now what you do is here, you have to define another class and implement that compare to method again. Sorry, comparator interface again. Implement the comparator interface again. Product name comparator, let's say. Product name comparator. So this class now, it implements the product, sorry, it compares the product objects based on the name. Override the compare to method. So if product one dot, so I'll directly do this. We don't need to already this is very important. All of you are try to understand this. Now names are string objects, right? So to compare the string objects, already in the string class, that comparison logic has been defined. Where it is in the compare to method of the string class. Already we got the code, you know, which is defined in the compare to method of the string class. So now what I'm going to do is I will simply use that method here. Okay. Yes. So I'll simply call that method. Will not write any if conditions and all. Simply we'll make use of that string class compare to method, which has got the logic to compare the string objects based on the name. Okay. Yes. So do this product one dot get name dot compare to of product 2 dot get name. That's it. So you see, when you call this get name method, it returns that string object, that name. It returns that name. On the name we are calling compare to method. Where is this compare to method defined? In the string class, you see, java.lang.string. So we are passing the other name, other product name here as a parameter to this compare to method. Now internally the compare to method already has got the logic to compare the string objects based on the text content. Names are nothing but text, right? So it's lexicographical order basically. When we talk about names, they're strings, and they are always compared, you know, based on the alphabets itself. We call it as lexicographical order. Okay. Yes, that's it. Now what to do? Now I want that elements that I want the sort method which you got here to sort the product objects based on the name. Okay. I want the sort method to sort the product objects based on the name. Now you can simply pass that comparator object reference, product name comparator. Just a minute, please. Yeah, I'm sorry. Product name comparator. Yes, sorry. You see, now we are passing this product name comparator object reference. In the product name comparator class, just a minute, please. Yeah, sorry. So you see, we are passing this product name comparator object reference to the sort method. So sort now the sort method will call the compare method of this product name comparator. In turn, compare method is using the compare to method of the string class, which already got the logic to compare the text content, that names now based in the alphabetic order or the dictionary order, we say, right? Yes, that's it. You see, this time the sort method will sort the elements based on the name now. Okay, so let's give different names here, not rather than calling them as product name, product 2, product 1. Okay, yes, even if you leave it like this, still it works, not a problem. Okay, let's see. You see, on the name, product 1, product 2, product 3 and 4. So first 7 characters will be matching on the last character, that number makes the difference. Let's say I'll give some other names. Let's say, U310. Okay, one. Next, Expedia. Okay. Next, something else. Tata Sky. Okay. And something. Um, Samsung E7. Let's say. Samsung Edge. Okay, fine. Let's say these are the products. Okay. Now you see the names here: U310, Xperia, Tata Sky, Edge. These are the names. Now let me run this code. The products will be arranged in the dictionary order of that name. You see, Edge comes first, E, then Tata Sky, then U310, then Xperia. Okay. Yes. This is the most common requirement in real-time logics. You have to write that sorting logic, especially to sort that records. You have to display the records. You might have noticed it already. Sorting on date wise. Let's say you have made some transactions, with your account. So you will view the transactions, and then you have an option to sort the transactions by date, by amount, right? Or debit transactions or credit transactions. So you have that option. Sometimes few online bank applications provide that option. You have to do that. Yeah. So is it clear for you people, all of you? Okay, good. So hope everyone got it. Now let's move on. This is about the list type collections, I can say. So far we have discussed about list type collections. Now we got set type collections here. That is the next thing which we need to talk about. Okay, set type collections. So let's see the set type collections. The set interface, it represents set type collections. You see, it extends collection interface. But you will find that in the set interface there are no additional methods. So this interface represents set type collections. When I say set type collections, that means the collection object with unique elements. Set represents a collection object with unique elements. Okay, set represents a collection object with unique elements. So duplicates are not allowed. Duplicates are not allowed here. Yes. Okay. Now you see the set type collections, they are definitely different from a list. First of all, the elements internally they are not stored based on the index. Index is not valid here. Okay, the elements are not stored based on the index value. Index won't play a key role here, but instead the hash code values play key role here. Yes. But just before we proceed any further, so hope everyone remember the hash code values, right? Hash code. So what is hash code? Yes. Where did we come across this hash code? Hash code plays a key role, you know, when we talk about storing the elements in set type collections. Yes. Serialization of objects. No. In the object class, when I was talking about object class, see, we have come across a method called as hash code method, right? Yes. It's not memory address of an object, okay? Please. But hash code value is generated by a hashing algorithm which takes memory address of the object as input. Hashing algorithm will be there which generates that hash code value which is an integer value, but that hashing algorithm takes in memory address as input. It will take the memory address as input and generates the hash code value. And you can't take this hash code value of an object and regenerate the memory address, okay? You can't do that. Yes, fine. So for every object you'll have a hash code value which is an integer value. You people know that, right? Yeah. So now that hash code value is going to play a key role. So let's see how it is used. Now, one of the collection classes which you got here is hash set. Okay, hash set. Hash set class. So hash set is a class, collection class. Internally, it uses hash table data structure to store the elements. You know, data structures, why they are used. So they are used to organize the data into the memory. Now, hash table is one such data structure. So far, we have discussed about the data structures like array list, linked list, stack, and all. Yeah, you'll find that here. Hash table is also a data structure. Is anyone familiar with the hash table data structure? Can someone explain this data structure? Yes, hash table data structure. No? Okay, don't worry, I'll explain it. In a hash table data structure, you'll find that there are two key components in hash table data structure. So number one is hash function, and number two is uh, an associative array. Yes. So these are the two key components of hash table data structure. Okay. Yes. Hash function and associative array. So whenever you try to add an element, you see, so that element's hash code value is passed as input to this hash function. So input for the hash function is hash code value of that object. Okay, hash code value. And the output is index, which can be used to store the element into associative array. Okay, now associative array, you know it holds the elements or associative array, I can say that elements are stored into cells called buckets. We say buckets. Bucket or buckets. Buckets is plural. Bucket is singular. Okay. So I'll show you people. I'll show you people an image, so which helps you people to understand how it works. Okay. Yes. You see, for suppose let's consider this hash table. Now we are adding three elements. Okay. I want to add three elements to the hash table data structure. So you see, let's say first of all the first element is passed. Element 1 is passed. So when element 1 is passed to this hash function, actually when we try to store this element 1, the hash code value of that element will be read. The hash code value of that element will be passed on to this hash function here. So hash function in turn what it does, it takes that hash code value of that element. Element means any object. Elements are nothing but the Java objects which you add to the collections. Collection is nothing but it holds group of similar objects, right? Collection of objects. Yes, collection is nothing but it represents a collection of objects, I can say. Yes. Okay, fine. So you see that hash function, it takes the hash code value of that element, and it returns the index which can be used to store this element into associative array. See, what is the index now which is generated for element 1? It is 2. The index which is generated for element 1 is 2. So at that index 2, you see we call them as buckets here. The element 1 is stored. Yes. Now again, if you pass element 2, if you want to store element 2, and again the hash code value is passed. So let's say the index which is generated is 0. So that element will be added at 0th index. The element will be added at 0th index here. Okay. Yes. Next, element 3 is passed on to the, let's say, to that hash table. Just a minute, please. Just a minute. Just a minute. Yeah, I'm sorry. Okay. So you see element 3, I'm talking about element 3 here. So when element 3 is passed on to the sorry, element 3's hash code is passed on to the hash function. So now the hash function generates the indexes too. But already there is an element at index 2. So what happens to this element? This element also will be added at index 2, no problem. Okay. So you see internally you'll have a linker list here. So one element will have reference to next one. So that is how internally the elements will be stored here. Yes, that's it. So this way your hash table data structure works. So if you try to add three elements, let's say it index, sorry, no, each element means I'm talking about objects here, Java objects. Now the elements hash code values read and it is passed on to the hash function. So which generates a index value which can be used to add the element to the associative array. Yes. So similarly, the same is the case for element 2 and 3 as well. Okay. Yes. Okay. So now you see for every element index is generated based on the hash code value and it is added to the associative array here. Yes. Okay. Now what is the advantage of using such a data structure? Is anyone familiar with this? What is the advantage of using that data structure, hash table data structure? Yes. Do you see any advantage for hash table data structure? Yes. So you see any advantage for the sorry, for this hash table data structure? So I can say definitely yes. Search operations will be optimized here. Operations are optimized, so it would take less time here in case of hash table. How? Let's see. For suppose if you consider array list data structure, we'll compare it with array list. You see, earlier we discussed about these two data structures, linked list and array list, right? Out of these two data structures, search operations will be, or reading the element here, will be faster in array list compared to linked list, right? Yeah. So now, For suppose you want to search an element in the array list. You want to just check whether an element is present in the array list or not. For suppose in that array list you got 100 elements. Just assume that in that array list you got 100 elements. So now what will be the worst case scenario here? If you got 100 elements, let's say worst case scenario will be, let's say the element is at 99th index. In that case, you will start searching for the element from right from the 0th index till 99th index. That means how many indexes you have to search here to check for an element, to search for an element. How many indexes we have to search? In this case, how many indexes we have to search? 100 indexes, right? So we have to search for 100 indexes. Yes. Worst case scenario is search for the elements in 100 indexes. Okay. Now, what if you got the same requirement? You have to search for an element in the hash table data structure. Let's say you got 100 elements in the hash table data structure. Okay, you got 100 elements in the hash table data structure. So in this case, how many indexes we have to search here? Only one. Okay. How one in this case? Let me explain it. You see, in this case, we don't need to go to each and every index and search whether the given element is at that particular index or not. In case of array list, you have to do this. In case of array list, you have to do this definitely. But in case of hash table data structure, we won't do this. In case of hash table data structure, you see, we'll take the element and that element which you want to search, the hash code value of that element, you'll pass it to the hash table data structure, right? So to this hash function, I'm sorry, the hash code value of that element which has to be searched, which has to be searched here. You see, that hash code value of that element is passed on to the hash function. So hash function, what it does, it takes that hash code value of the element and it will return the index of that element. Okay, it returns the index. So in that particular index, if you find that element, that's it. Otherwise, it's not guaranteed that you may find the element. You may or may not find it. If you find it, well and good, I can say. the element is there in the collection. So if you fail to find that element, then I can say the element is not present in that collection. That's it. Because you see, this hash function will generate the indexes for each element. And that index for a particular hash code value is going to be same always. For the given hash code value, the index is going to be it is going to be same. I'm sorry. The is going to be same. So that's the reason why you will find that here later on, if you want to search the element, you can simply read the hash code value of that element and pass it to the hash function, which returns the index value of the element. Yes. So this is very quick, right? But we don't need to really worry about the implementation part here. Okay. Yes. Fine. So we got a class now, hash table class, sorry, hash set class, which will take care of this data structure. That means internally it will be implementing it. So it will take care of storing the elements. Okay. So you see, I'll change that collection class from vector to hash set. See? Okay. You see, these are the elements which you got. Just I've changed hash set class from vector to hash set. That's it. So remaining things will be same. Let me run this code. So internally, there's that elements are stored into hash table data structure. Okay, the elements are stored into hash table data structure here. So this is how it is displaying the elements. That means we got the elements in that order now. Okay, so I hope this is clear. You see, the order in which we have added the elements, is that order maintained? Okay, if no, I can say yes, but it doesn't matter. So we can't add duplicate elements here. Okay, so it won't take duplicates. Okay, so this is about hash set. So let's move on. I was just waiting for you people. So if you got any doubts, so I didn't get any doubts. Okay, fine. So that means not me. You people didn't get any doubts. Okay. So hash set class is again, it got a subclass. You see that linked hash set class, it extends hash set. Linked hash set class extends hash set. Okay. Yes. So I want you people to explore the linked hash set class on your own. I'll just leave it to you people. Okay. Yes. Now, you know, when we talk about set interface, see, again for the set interface there is a sub interface. For the set interface, we got a sub interface here called as sorted set. Okay, sorted set is a sub interface. It extends set interface, and sorted set actually represents ordered collections. Sorted set represents ordered collections or sorted collections, you can say. Ordered collection means ordered collection means what do people think? Ordered collection. So ordered collection means you can say the elements in this collection, they are stored in the order, in the sorted. They are sorted, I can say. The elements of this collection are sorted based on the natural order of that elements. Okay, based on the natural order, whatever order is default for that particular type of element, that order will be maintained. Yes. So ordered collection means it is nothing but a collection of elements which are sorted. It's a sorted collection, I can say. Sorted collection. Yes, it's a sorted collection. Okay, fine. Now see, there is a class which implements this interface sorted set. It is tree set. Tree set. Tree set is a collection class which implements sorted set interface, and sorted set represents ordered collections. That means where the elements are stored in an order, they are sorted in an order. What order? It depends on the natural order. Okay, fine. You know, here the tree set internally, when we add elements to the tree set, it will sort the elements and it will store them internally. So we don't need to call the sort method explicitly here. You see, I'm changing that collection class type from hash set to tree set. Okay, see, now it is tree set. Yes. So now here, you see, the tree set we got this elements, we are adding this elements, right? Now the tree set, when it stores its elements, it will sort them accordingly. It will sort those elements and it will store them. Now tree set, in order to sort the elements again, it is going to use the compare to method of the class. We got compare to method, it uses that method. Now in this method we have written the logic to compare the objects based on the ID. So this class implements that interface, right? Comparable interface. So by default it uses that compare to method defined in the product class to compare these objects, and it will sort them. Let's see. Now they are sorted based on the ID. You see, product ID 101, 102, and so on. So that means now what you need to understand here, tree set, the elements which we add to the tree set, they should be always comparable. The elements which we add to the tree set, they're supposed to be comparable always. Otherwise, you can't add the elements to tree set. Okay, fine. Now, I have a question for you people. You see, now tree set by default it uses compare to method to compare the elements, and then the compare to method, you see the logic how it is written. The objects are sorted based on the compared based on the ID. Yes, the product objects are sorted based on the ID. Yes. Now, next here. What if I want the elements to be sorted based on the name or based on the price? I want tree set to sort the elements based on the name or based on the price. So what to do? What if you want the elements to be sorted based on the name or price? So what to do? Uh, I want that compare to method to be retained like that. I want that compared to method to remain like that. I don't want to change the compare to method. Okay. So in the compare to method, we got the logic to compare the objects based on the ID, right? Based on the ID. I want to retain that logic. You see, again, you'll go for comparator here. So already we have these classes which we have implemented, right? So the product name comparator class, so it implements comparator interface which compares the objects, product objects based on the name. Now I want the objects to be compared based on the name. So I can use this product name comparator object now. So that logic which is defined in that compare method, we can ask the sort tree set method to use it. We can ask tree set to use that logic. How? So to the tree set class constructor, pass the product name comparator object reference. That's it. Pass product name comparator object reference here. That's it. So what? So what happens if we do this? You see, now the tree set will take the product name comparator object reference and it will sort these elements based on the comparisons that will be based on the name. How? Because tree set will use this compare method which is comparing the elements based on the name here. Yes, that's it. Okay, we can explicitly pass that comparator object reference to the reset class constructor. We are passing that comparator object reference to the reset class constructor here. You see, that's it. Now you should see the elements are sorted based on the name. You see, Edge first, then Tata Sky, then U310, then Xperia. Okay. Yes. So is it clear for you people? All of you? Can I have yes or no? So hope this is clear. Good. So this is very important in the collections. Okay. Yes, very, very important part. Yeah, fine. So now we are done with the set type collections also, I can say. So we got maps. They won't take much time, but I will talk about it in the next class. Okay. So maps, again, you'll find that they are slightly different. After maps, I will talk about few more topics tomorrow. Tomorrow I'll be done with collections and few miscellaneous core concepts. Okay, and then we'll start with JDBC API, which we'll see how to connect to the database. Thread programming, I'm planning it this weekend, special class for thread programming. Okay, so we'll start with JDBC. That will be advanced concepts from day after tomorrow. Okay, yes. So tomorrow we'll talk about maps and followed by few miscellaneous core concepts like generics, okay, and enums concept and all. Fine. Yeah, variable arguments. Yes. So that's all for today.